Hi there. In this project, we implement an accelerometer-based wireless sensor node with an Arduino Uno board. The wireless sensor node gets the readings from an accelerometer and sends the data to a base station for further processing. We can see here the wireless sensor node. You can see that it is based on an Arduino Uno board, which has an XB shield on top to put a next RF transceiver from Chiseco, which will perform the wireless communication. On the left you can see the accelerometer. It's an MMA 7361 from Freescale Semiconductors, and the power supply is simply a 9 volts battery. The base station instead is simply an SRF stick from Chiseco. You simply have to put it on your computer and it will perform the communication with the previous transceiver just transparently. Now let's see the system working. This is the wireless sensor node, and this is the base station, which is, as you see, my computer with the SRS stick on the USB ports. And you can see I am running MATLAB on my computer. We will use MATLAB to create a graphical user interface with 4 different programs to show the readings from the accelerometer. Each of the programs will show the readings in a different way, as we will see, and it will show us different applications of the accelerometer data. Here I am running the program. It is called GUI, obviously for graphical user interface. It will take a second to open, and you can see the interface here. I just selected the communication port, which is in this case COM3, and as you see, we can also select in the program the sampling frequency, the display frequency, and the time window for which we want to see the data. In the panel below, we can also select the plot type that we want. We have 4, as we said before. The first one is 3-axis acceleration. It's the simplest one and the most intuitive one. Then we have pitch and roll, then angular cursor, and then position cursor. We will start now with the 3-axis acceleration. Just click start, and here we can see each of these plots shows the acceleration on a different axis, X, Y, and Z. In this moment, obviously, there is no dynamic acceleration in either axis, but in the Z axis we can see the acceleration of gravity, which is 1, because these plots are actually in G scale, meaning that 1 is 1G, being the acceleration of gravity. Now here we will show the dynamic acceleration. Here it is in the x-axis, we can see the waveform there. Here it is in the y-axis, very clear. And now up and down, it will be in the z-axis, it will fluctuate around 1G. Let's change the plot now. We will show the pitch and roll. Pitch and roll are actually the angles of rotation around the x and y axis. And we will show it as a simple box, which will represent the actual sensor node. And as we see, it will follow the movements around the x and y axis of the sensor node. It is a very intuitive situation, but it doesn't detect rotations around the z-axis. For physical reasons, it's impossible to do it with only an accelerometer. We would need another type of sensor. We change now to the third type of plot. It is angular cursor, and it follows pretty much the same principle as the pitch and roll. In fact, it also finds the pitch and the roll, but it will work like a cursor, possibly like a Wii remote, which will just map the pitch and the roll to x and y displacements. Here you can see it works like a simple cursor. If I move it up, it goes up. If I turn to the left, it goes to the left. Turn to the right, goes to the right, and so on. So this was an angular cursor because it mapped angular values, which were the pitch and roll, to displacement values on the screen. A position cursor instead should work like a computer mouse, which maps displacement to displacement. I mean, vertical displacement to vertical displacement and horizontal displacement to horizontal displacement. We can see that it is very hard to make it work because it relies on double integration of the acceleration, and with accelerometers, because of their intrinsic noise, it is very hard to make it work. In fact, you have to use some type of algorithm with thresholds, and the one we used is very primitive and it doesn't really work as expected. But no one really uses accelerometers for these type of cursors. So this is it. Thank you very much for watching, and goodbye.